So we have another challenge from UID11, someone who's made a lot of the TypeScript challenges. TypeScript has a structural type system, he says, and sometimes you want a function to accept only some previously well-defined unique objects, as in the nominal type system, but not any objects that have required fields. So create a type that takes an object and makes it and all deeply nested objects in it unique, while preserving the string and numeric keys of all objects and the values of all properties on these keys. The original type of the resulting unique type must be mutably, I think they mean to say mutably assignable, but not identical, or mutually assignable. Okay, I just can't read very well. That's all right. Everybody knows this by now about me. So here we are. We have quux and foo. I think, what's the sequence? It's like foo, bar, baz. There's something with
I think that's right. Foo, bar, baz, quux.
Quux. And then there's the fifth one it's longer. I don't know. Okay. Let us know below if you remember. I learned that from John, I never know how to say his last name. It starts with GJ, the Rust guy.
Oh yeah. Yep. Love his stuff.
So, okay, let's take a look. So we have, this is our thing. This is the thing we're implementing, deep object to unique, and we're passing in quaz. And then we get back quaz. We pass in foo, we get back foo. Fine. But if we pass in foo, like the foo and then index, then we're going to get the same thing. So basically, let's look at our inputs here. Okay, so does the problem space make any sense to you?
No, not yet. Okay. I don't think. What's unclear to me is how is it different than just like wrapping the same type? I think. What's actually changing in the type that we return from like deep object to unique?
Yeah. So like let's look at bar and foo in this case. So, so bar here. Okay. You know what? I think this is one of those cases. So this is a hard one. I think this is one of those cases where it will make sense to just look through the solution. So
sure.
Basically, we're using we're adding uniqueness to an object deeply. Mm-hmm. So
so like even if it is the same value
yes.
or type, like we're going to treat it as different. So like foo of foo is 2, foo of bar is 2, but they should not be equal. I see. Okay.
Yep. Yeah. I'm sorry. Yeah. This is an important distinction. These ones here are not equal. These ones here are equal. I messed that up.
Oh yeah.
So
no worries.
Important difference, I suppose. So we're going to be adding. Okay. So basically, yeah. I mean, you tell me. I think look through here and tell me what you think as you're reading through it.
Sure. So we're mapping over the keys of our initial object, and then for each of those keys, if it extends an object, we're going to recurse into it. Otherwise, we just return that type. Yeah, which is kind of what I was thinking. Oh, I see. But then we're intersecting it with a symbol. Okay, interesting. Is that the actual type symbol? Like the type?
Yes.
Yeah.
This is
interesting.
This thing here is arbitrary. This is just a name.
Right. Yeah, that's the key. But then the symbol is actually cool. And then the symbol is U, which is our second, just some other generic. Doesn't matter what it is really. Okay. So this is like branded types where you're like branding at every single level.
Yes. It's like
that is types. Pretty cool.
Yeah. So yeah, that's basically spot on. Yeah, I think so. We see here that we have symbol or quaz. If we hover over, sorry, so you can't see it, but if we hover over A8, for example, we have symbol or quaz, which is the keys of the thing that's returned. Like if we go to A7, we'll see that we have the value quaz, but we also have a symbol key with the kind of path leading up to this point. So
right.
Yeah, then that's how we make each path unique, because the U part is a tuple containing the current path, and we append to that tuple when we recurse by passing it in from here. So yeah, and then like let's look at A4. If we hover over A4, we just get 4. Oh yeah, because that's the actual value for quas. Okay, makes sense.
Interesting. So we're not branding the individual values. We're kind of branding each level of this nested, like deeply nested object.
Yes. Yep. I think that's
cool.
That's exactly right. And then let's look. Sorry, there's so few challenges that use not equal. I was caught by that. Oh wow! If you hover over, deep object to unique on line 88, I didn't mean to, but there's it's like a pretty hilarious. I need to like take a screenshot of this. Okay, it's a pretty hilarious thing. So this one takes a slightly different way of going about things. Are you familiar with this syntax, a unique symbol?
No, I haven't seen that one before. I mean, I'm kind of familiar with symbols like in the JavaScript. Yeah, go ahead.
It's a super deep tracks TypeScript thing. It's not JavaScript. There's a way of describing in the type system unique symbols, and I put a link here on the screen for anyone interested. But there's like a whole different universe when you start talking about symbols. Symbols have a lot of strange things going on, and you might be asking, what is a non-unique symbol? Actually, it's possible to make a global symbol that's kind of like registered such that you can get it back at any point in the future, even if you didn't have the reference originally. Usually people don't use symbols that way that I see. Usually people create a symbol and then they pass it around as a, like to keep it. But there is this syntax to differentiate between the two. So I think it's kind of interesting. All right. So there is still this intersection part here. We have read only, optional, sim is the symbol thing itself. So, okay. This one, I think, makes it even harder to understand what's going on.
It looks like we're like branding at 2 levels here, which is interesting to me. I'd be curious to see like what does that look like?
So what it looks like is it's going to be at a top. Well, I'm getting let's go look for one that we saw before. A5 maybe. Yeah. Well, it's giving me a ...
Same.
We can't really introspect.
But if you hover over like A7, you can see that essentially it looks like it's branded twice. Although it's not showing us what the brand there is, but it's like intersected with 2 other things, which makes sense because we're intersecting at the top level and then also within our conditional type there. Yeah,
this is a puzzling one. I did find one. I'm not sure. I guess I just don't have an answer for you. I'm not sure exactly what's going on with that and how that works because we can't look at it. There's a debug type here somewhere, but I also found this one. This one doesn't work. It fails. Let's see. It fails A1. So I think the reason it fails A1 is because we haven't actually nested yet. Like we haven't gone deeper. So it fails at the top level. All of the other like paths work, but this, I think we really need like maybe this, if I could get rid of these and this, maybe it would pass. No, it doesn't. Oh, because we have to have symbol. Well, anyway, we could mess with it, but I just thought this was interesting as a nope. This doesn't handle the case. And I saw a couple people, I bring it up because I saw a couple people on the challenges online doing this, and I thought it was kind of interesting. Oh well, I feel so incompetent looking at these things, or so like, you know what I mean? Like less than, but that's okay. I think the broad concept here is we're trying to do some stuff to an object to make sure that if we compare it to something later, that it's not equal. So, because TypeScript is a structural type system, meaning that things of completely different names will be equal if they are structurally equal, if they have all the same properties and values. If we run into a situation where we don't want that, that's where a type like this would be useful. You know?
Yeah. Cool. Yeah, that makes sense.
Hopefully I salvaged
something
this
a little
video
bit closer. I was going to say, it gives you something a little bit closer to like, if you're coming from a language, maybe like Java or something, where types are not structural, then this gives you a behavior that's closer to something like that.
Yeah, great. Okay, well, we do have one more that's sort of like this at the end, so maybe we'll stick around for that one. Okay, on to the next one.
All right.